All right, continuing on, we're still doing with the Arctic Circle, latitude 66.5. We know the maximum altitude of the sun, the minimum altitude of the sun. But what I want to know is what is the declination of circumpolar stars? And I told you how to do that. It's really easy. You just took 90 minus your latitude. And 90 minus 66.5 is 23.5. So everything with a declination greater than or equal to 23.5 degrees is circumpolar. But on the summer solstice, what's the declination of the sun? It's 23.5 degrees. So on the summer solstice, the sun doesn't set. It makes a circle that goes around like this. So if you were there, it would get real high, it'd get up to 47 degrees and it would go down, but it wouldn't go below the horizon and it would come back up again to 47 degrees. And you have 24 hours of daylight. So on the Arctic Circle, you get 24 hours of daylight on the summer solstice, you get 0 hours of daylight on the winter solstice. That's why it's a very special spot on the Earth. All right, let's see if you're understanding this now. Still talking about seasons. The Earth, here's the sun. Here's the Earth going around the sun. Notice that this is the rotation axis. This is straight up. Remember, the angle here is 23.5 degrees. But as the Earth goes around the sun, that 23.5 degree angle always stays the same. It's always pointing off to some direction. In this case, it's pointing towards the star Polaris. Got on the way to show it to you here. This is my little demo. So let's see if I got this. Oh, let's do it this way. Okay. So you can see this. This is the Earth, and this angle of the tilt matches that angle. But as the Earth goes around the sun, comes over this side, it's now tilted this way. So the North Pole, in this case, is tilted towards the sun. Here it's tilted away from the sun. And then when we get over here, we're back to this position again, where it's tilted towards the sun. Well, when we're tilted towards the sun, if you live in the northern hemisphere, that is when we have summer solstice. So in the northern hemisphere, summer solstice occurs when the North Pole of the Earth is tilted towards the sun. And this is winter solstice when it is tilted away from the sun. So, if you got this figured out, I can go like this and I can say, what is this? Is this summer solstice or winter solstice? You should be saying that this is summer solstice because you see the North Pole is pointed towards the sun. But if I flip it around, try to confuse you. Let's do that. What is that? Now the North Pole is pointed away from the sun. This is winter solstice. Okay? So that's why the sun changes its declination in the sky, is because sometimes the North Pole is pointed towards the sun, sometimes it's pointed away from the sun. What does this do? This makes the sun get higher in the sky. Now, I haven't even talked about why we have seasons yet. There's 2 reasons why we have seasons. All right? And these are important because people get this wrong. A lot of people, if you ask them, they'll say, why is it warm in the summer? It's because we're closer to the sun. That is totally wrong. We're actually closest to the sun in January, right in the middle of winter. So being closer, further away from the sun is not what's creating our seasons. What creates the seasons is the fact that the sun's higher in the sky. So if sunlight is coming in from a very high angle like this, sunlight is just energy. That energy covers a certain area on the ground and the ground absorbs that energy. So the sunlight, when the sun is very high, it can absorb a lot more energy than it can when the sun is low. When the sun is low, that same amount of energy coming from the sun is spread out over a much bigger area than it is here. So the amount of area getting heated by the sun is much, much bigger, and so the earth does not absorb as much energy. So what we say is this gets more direct light, meaning the sun is more closer to being perpendicular. The higher it is in the sky, the more energy is absorbed from the sun. When the sun is low in the sky, the earth doesn't absorb much energy. If you lived in the South Pole, you get just as much sunlight as everywhere else on the earth. And the sun is putting out the same amount of energy. The problem is the sun is so low in the sky, the ground can't absorb as much of that energy, so it never warms up. That's why in the summer, the sun is very high, we absorb all that energy. Two reasons, right? So one reason for the season is more direct sunlight because the sun is higher in the sky. The second reason we already talked about, but when do we have the longest days? We have the longest days in the summer too. So even with the light more direct, we also have more hours of daylight. So there's more time to absorb that energy coming from the sun. And less time in the winter. So the sun heats up, or all its energy is being absorbed by the ground. Well, if it has 14 hours to absorb energy, it's going to absorb more energy than if it only has 8 hours to do it. Especially when the sun is much higher in the sky. So those are the two reasons we have seasons. Both of these are caused by the tilt of the earth. So the tilt of the earth is what creates the sun moving higher and lower in our sky, which is why we have seasons and we get more energy from it, or we absorb more energy at different times of the year. The sun gives off the same energy all year long. All right. So far, so good. Let's talk about a couple more specific things on the earth. So here we're going to do, this is a big earth right here. We're going to talk about very special spots on the earth. So sunlight coming in from a long ways away is pretty much coming in parallel because it's 150 million kilometers away. On the summer solstice, remember the summer solstice, the north pole of the earth is actually pointed towards the sun, and it's got a tilt of 23.5 degrees. So this is the north pole of the earth, this is the south pole, this is sunlight. Okay? All right. But 90 degrees away from that is where we have the equator. Okay? But on the summer solstice, where the sun is directly overhead is somewhere over here, where the sun would be hitting exactly overhead. That angle is at 23.5 degrees. So we draw a line of latitude at 23.5 degrees, and on that day of the year, the summer solstice, June 22nd, the sun is directly overhead. We have a special name for that. It's called the Tropic of Cancer. It was called the Tropic of Cancer because originally when they did it, the Tropic of Cancer, or the sun was in the constellation of Cancer on the summer solstice. Now that's changed because of precession. And if you're up here, in this region up here, see right here, sunlight goes all the way back to the back edge. So anybody up here would get 24 hours of daylight as they rotate around. And if you're on the North Pole, the sun would be 23.5 degrees high, and it would just go around the horizon at 23.5 degrees high the whole day. Then it would get a little bit lower every day until it went below the horizon. If you were down here in the South Pole, so we call this the Arctic Circle. And the latitude of this is 66.5 degrees north. You're like, oh, do I have to memorize another number? No, you just memorize 23, but you remember this is 90 minus 23.5, you get 66.5 degrees. That's why it's at that. And down here, these guys don't get any sunlight because they just go around the South Pole, and so the sun never comes up. This is called the Antarctic Circle. And it's at latitude of 66.5 degrees south. And for completeness, I'm going to put in the Tropic of Capricorn. At 23.5 degrees south. It doesn't really have any effect on the summer solstice. But now let's do the same thing when the Earth is on the other side of its orbit. When it's on the other side, sunlight's now coming this way. And now our Earth is over here. Okay. And same thing, but the North Pole of the Earth is still going to be at this angle here. This angle is still 23.5 degrees. This is now the North Pole of the Earth. So the North Pole is now pointing away from the sunlight. Over here it was pointing towards the sunlight. This is the winter solstice.